All right, for this problem, we are looking at a function that is linear. So this is our function, and we can see that it is of the form f of x equals mx plus b. And that is how we're going to find the slope and the y-intercept for this function because it's directly in this form already. So we already know that m is our slope and b gives us the ordered pair 0b for the y-intercept. So when we want to identify the slope, we go ahead and just say m is equal to negative 2/3. And that means the y-intercept, so b is equal to 4. So this implies that my y-intercept is 0, 4. So these are my two answers that I want. Now to sketch the graph, all we have to do is use that slope and intercept. So first thing is to graph the intercept. So I have 0, 4. So right here. Okay. And my slope. So m equaling negative 2 over 3. We can always think about this as rise over run. So I can go down by 2. So that's where that negative 2 is. And then I'm going to run. So I'm going to go positive 3. So that's where I'm going to have another point on my line. All we have to do now is connect the 2 points. Label them. And you have your graph. Okay. Now looking at the next part, it's asking, is f increasing, decreasing, or constant? Okay, and how could you tell without the graph? Well, from the graph itself, we always read from left to right. So when I look at the graph, I note, is it going down or up when reading it left to right? Notice it's going downward. So that means that it is decreasing. And we could know this even without looking at the image by simply knowing that the slope is a negative. So we can know this by the sign of the slope. So whether it's negative or positive, it's being negative means that it's decreasing. If it were positive, it would be increasing. If we had a slope that was 0, it would be constant. Next, what is the average rate of change of f on the interval from negative 1 to 3? And would your answer change on a different interval and why? So this one, we're going to do a bunch of work here, but honestly, you don't need to do all that work because we're going to find out we're going to get the same answer. So our average rate of change formula that we'd seen before, so that's equal to f of x2 minus f of x1 over x2 minus x1. And like I said, by convention, usually I'm going to have x2 be greater than x1. So just to keep myself doing the same thing. So f of 3 minus f at negative 1 over 3 minus negative 1. So now all I have to do is plug those values into my function to find out what f at 3 and f at negative 1 are. So going back, and I have negative 2/3 x, negative 2/3 x, 3 in this case, plus 4, that's the first one, minus negative 2/3 times x, which is negative 1 in this case, plus 4. all over, and then it's 3 plus 1 technically, so we have over 4. Continue this up here. So what we're going to have now is, so when I go to multiply, I get negative. So it cancels, these ones cancel actually. So this 3 cancels with this 3. And then that just becomes, so I have negative 2 plus 4 minus, and in here, negative 1 times negative 2/3 gives me a positive 2/3 plus 4 all over, and then 4 again. And so this becomes a 2 for this, the front one there. And this then becomes 2, then plus 12 over 3, all over 4 still. So then this is 2 minus, and so I have the negative 13 over 3, all over 4. So then I need a common denominator for the top. So then this is 2, actually, just do 6 minus 14 over 3, all over 4. So I get negative 8 over 3 over 4. And so this becomes negative 8 over 3 times 1/4. And so you get negative 2/3. That's all is to show you that you're going to get back the average rate of change is, going back to the beginning, the slope of the function. So what you see is, if it doesn't matter which 2 points you choose, so notice here or here, any 2 points, you're going to have the same rise over run, which means you're going to have the same rate of change every single time. So you don't need to do all this. Okay, all you would need to do is say the average rate of change is equal to the slope, which is then just negative 2/3. So you would start here with just cut out all this this stuff and just answer it with that. That's all you do. Okay. So all you need to know is the slope. You don't need to do all of that. All right. Next, what is the domain of f? Is this the domain of every linear function? So f's domain, and when we look back at it, when we actually look at, notice that it's going to the left forever and then to the right forever. So that means I'm going to cover all real numbers. Okay. So the domain is negative infinity to infinity. Okay. This is true for any line. So if I show you, so let's go ahead and consider the 3 types of linear functions. So the first type is that we can have an increasing function, we could have a decreasing function, and we can have a constant. So is this a domain for all linear functions? Yes. As you can see, they are going to cover left and to the right, all values. Okay. For all linear functions. There we go. And so that's where we have. Now, what is the range of f? And is this the range of every linear function? So let's look at range, considering these images here, and even the one here. So this one is a decreasing function, as we said before. So it's range. So this side goes up forever, so it's upward, and this side's going down forever. So that means I have all real numbers for my range. Now looking back at the 3 different types of linear functions, Is this the range for every linear function? Well, for increasing, we're going to have this side go up, this side go down. So I'm going to cover everything. Decreasing, just like we saw for this one, this side goes up, this side goes down. So we'll cover all y values. But on this one, constant. It doesn't go up or down. It stays the same. So that means that the constant function is only going to have one value for its range. So no. So this is not the range for constant functions. Okay. Is it odd, even, or neither? So looking back, remember, to be odd means that you are, let me get my thing. Here is the origin. You are going to be then do a 180-degree rotation, and therefore the graph would go back to the same image. But if I did a 180-degree rotation on this, my graph would actually be down here. I don't get the same image. So that means that I'm going to say no, this is neither actually. When I look at even, to know if something's even means that it is symmetric with respect to the y-axis. So what image would be on this side, if I folded this over, would lay back on this side, it would look like the same thing. Or if you did that flip, it looks exactly the same. This does not. If I flipped it, it would look like that on that side. Okay, so that is not the same image. So that's why I would say this one is a neither situation, where it's neither odd nor even. Okay. Under what conditions would a linear function be even? So to answer this question, so the function would, oh, I forgot the rest of the function, would have to be constant. So for it to be linear, so notice here's my axes. Let's get my axes in a different color. So my axes, if it's constant, notice that if you fold it in half vertically, it would lay back on itself. Or if you flipped it, if you think of this as a flip across the y-axis, then it would look exactly like itself. So that would be even. Okay. For it to be odd, okay, the function would be odd if it goes through the origin. So what that looks like is you have the axes. Imagine everything is straight. Come here. This thing is not straight. There we go. Better than before. Anyway, so this, imagine actually went through the origin. Be great. There we go. So it goes to the origin just like that. Doesn't matter if it goes through it upward or in a, so increasing or decreasing. Okay. As long as it goes to the origin. When you